In this lesson, we'll learn about functions. Functions allow to structure programs in segments of code to perform individual tasks. We've looked at um, functions already when we look at the main function. A function is a group of statements that is given the name and which can be called for at some point in time by the program. And the syntax is type of function, the name of the function, parameters being passed, enclosed in brackets, and the initialization of group of statements in curly brackets. Type is just the type of the value returned by the function. For example, if it is an integer that is going to be returned, the type of that function has to be int. If it is a string, the type of that function has to be a string. The name is the identifier by which the function can be called. The parameters are what are needed. Parameters consist of a type followed by the identifier, which will be seen in the example below. And the statements of the function is essentially the body. It's a block of statements surrounded by the curly braces. So in this example here, we see the type of the function int, the name of the function addition, and then we have two parameters, each with a type and the identifier. Followed by the declaration of the parameters, we see the curly braces and the ending curly braces. Within those curly brackets, we see a group of statements. In this example, we see that there's a declaration of a variable int, a variable r of type int. Then we see that the two parameters being passed are added and the result is assigned to r, and what is returned is r. We see another function, int main. Very interestingly, you see here that there is no parameter. In the function main, it begins by declaring a variable z of type int, and what is done after it's assigned the value of that variable becomes what the value of the function addition is, passing two variables or two values into those variables a and b. So we're passing 5 and 5, and the result is z. Functions with no type. Now that we're talking about main, previously we saw some examples, and we saw when void is being used. In the previous example, we looked at the function where we had a type, name, and the arguments being passed. It required declaration with a type. This is the type of the value return of the function. That's what we said. If it was integer, it would be int. If it was string, it would be string, and so on. But what if the function does not need to return a value? In this case, the type to be used is void, as we see in this example. Void print message is not returning any value, it's just printing something. The difference is the parentheses. The parentheses differentiate this function from other kinds of declarations of statements. because if we see the main function, we see the function print message being called, but although it's not returning anything, it's not being assigned to anything, you have to include the two parentheses, or else it would be just a variable being mentioned. So how we declare functions? Well, functions have to be declared before they can be called. Remember that in C++, identifiers can only be used in expressions once they have been declared. If we remember about variables, when we said that there's a variable x and we want to assign a value, that identifier x, which is an identifier of something, had to be declared. In the case of an integer variable, you have to have int x being declared. It could be initialized. Now the same thing applies to functions. The functions had to be defined. In particular, they had to be defined before the main function, which was the function where it is being called. If the main were defined before the other functions, then it'd be breaking the rule and it wouldn't be able to compile. So we would have functions being declared above main, and then within main you could call these functions. If this function was not declared before main and we had main and you call the function and the function is below main, you'll get a compile error. Now, for you not to get a compile error, you could declare the name of a function without initialization, without description. You could have main, and then here you would have the function details. Well, now we'll look at classes and objects. Classes contain data members, but they also contain or can contain functions as members. An object is an instantiation of a class. In terms of variables, a class would be the type and an object would be the variable. So if we look at int a, the class would be the data type, and the variable, particularly the identifier in this case, will be the object. Classes are defined using either the keyword class or the keyword struct with the following syntax. Class, class name, open curly brackets, closing curly brackets to encompass the group of statements. We have an access specifier and a member, an access specifier and a member, and the object name is the instantiation of that class. In terms of the access specifier, we could have three keywords being used: private, public, or protected. These specifiers modify the access rights for the members that follow them. Private members of a class are accessible only from within other members of the same class, or from what we could call their friends. Protected members accessible from other members of the class, but also from members of a derived class, meaning a class derived from a main class. And finally, the public members are accessible from anywhere where the object is visible. Here we have an example, class rectangle, and the object of that class rect. The class contains 4 members, 2 data types of type int and a void function and an int function, both being public. Now, it is interesting that these two, there was no access specifier declared because it wasn't, then the default is private. If we expand this program, we can see the example how it is being used. So we have the class rectangle. Again here, we have the 2 private variables, we have the 2 public functions. Notice that within this function area, it is going to return width times height, and then we have the void function that receives two variables of type int, but we don't see exactly what is done. Okay. However, below we see the declaration of the function setValues, which is from rectangle class, and we see 2 colons. These 2 colons are what is called the scope operator. It is used in the definition of function setValues to define a member of a class outside the class itself, because the definition of this member setValues declared here in the class is being done outside the class itself. That's when we use the derived or the scope operators. So then this is what happens within setValues. It is assigning the value of the 2 parameters x and y to width and height. Then in the main function, we see an instantiation of the class rectangle by declaring a variable rect. This becomes the object. So remember, just like a variable definition, this would be the type, and then this would be the identifier. So the type is of class rectangle, the identifier is rect, becoming the object. The way to call a public member would be the object dot the member. So when this is calling setValues, we are calling rect dot setValues. You do not write the class name because you already create an instance of the class when you declared a object of type of a certain class type. So you take it just as a identifier of a variable. However, you put a dot and then the member. So in this case, we're calling this function set values, and we're passing two parameters because set values, as declared within the class, accepts two parameters. In the definition of set values, which was done using the scope operator outside the class itself, we notice that what it does is assign x and y. Then we call rect.area, which is the other class, and we know that area, which is defined within the class, multiplies width and height, which in this case were 3 times 4, and the value is 12. What would happen in the previous example if we call the member function area before having called the function set values? Well, an undetermined result, because the members width and height, which are the two private integer variables, would have never been assigned a value. So the result would be something unknown. Now here in the screen we have an example of code using class constructors. A constructor is automatically called whenever a new object of this class is created, allowing the class to initialize member variables or allocate storage. Notice the definition of the class rectangle. We see the two private data elements there, the variables width and height, and we see the public declaration, and we see a function that we already know is being declared within the class. The function is area, returning the multiplication of width and height, and then we see a function here, rectangle, that receives two parameters of type integer. Notice that here the rectangle has the same name as the function, as the class itself. The way this constructor is created is because below we see the rectangle being initialized, receiving two parameters of type int, and then assigning those values to both width and height. This rectangle is not a function as the one that we had before, the previous example called set values, and like we said, it has the same name as the class itself. This is the constructor. The constructor has to have the same name as the class, and here the constructor is doing exactly what set class used to do, assigning the values to the arguments. Notice that these arguments that are being passed to the constructor, those are passed when at the moment when the object of this class is created. This is what is called. Here in the main function we have an instance of the rectangle class rect being created with the parameters being passed immediately. Rect with 3 and 4 and the object rect b with 5 and 6. Constructors do not run or are not called explicitly as if they were regular members. They only execute once when the new object of the class is created. If you notice, when this is created, we don't have any return when it's defined within the class, nor when it is explicitly defined. Why? Because constructors only initialize the object that's being created. In this case, object rect and object rectB. So at the moment of initialization, the parameters are passed to the constructor, which performs what was happening in our set values example.